Good afternoon, everyone. Welcome to the first data-intensive social science workshop series, which is part of IDEAS initiative. So if you don't know what IDEAS means, then welcome to data-intensive social science. And if you don't know what social science means, then welcome to the workshop. So so let me just briefly say a few things about today's workshop. So first of all, I want to acknowledge the effort for entire organization team, which includes Said, Tara, Gerard, and Caroline, alphabetically ordered here. So this has been, so this is going to be a first workshop. So a purpose here is to try to understand how are we going to work with public data sets and hopefully promote collaboration between different university units and scholars who work on social science. We are going to start with a round of welcome and introductions. So Gerard and Mara is going to speak about IDEIES SciServer and also overview of Sheridan data service offerings. And starting from 1:25, we are going to have two exciting presentations given by Professor Andrew Ching, who is a professor of marketing and also public health, and followed by Kurt, who is going to talk about, from education perspective, how to use public data to contextualize schools' education research. And we're going to take a 15-minute break, and coming back at 3 o'clock, I'm going to do a panel discussion. So as you can see, this is a multidisciplinary and cross-unit discussion. And so we hope this initiative will inspire some interest among attendees, and hope this will be a successful beginning of an ongoing series. And thank you all for coming. And without further ado, I want to introduce our next speaker here, Gerard, and who is IDEIES Director of Science and SciServer lead. Gerard, do you have slides to share?
Yeah.
Okay, so let me just stop here, so you can share yours.
Okay, I will give, I hope, can you hear me? Yes?
Yes.
Good. So I'll give a very short presentation where I give a little bit of a background on the Institute of Data-Intensive Engineering and Science, IDEIES that's organizing this, and on SciServer in particular, and then come up with some questions on why we're actually interested in hearing from you about how you might want to use public data and how we might be able to help. Basically, Jim Gray, who has worked a lot with Alex Saleh, who is the director of IDEIES, he at some point stated the fourth paradigm that basically says that science is more and more data intensive, where larger and larger data sets are being analyzed using ever more sophisticated tools and algorithms. So this is where we are working, but it's not very trivial because data is growing a lot. It's growing exponentially still, which means that to be able to handle large amounts of data, you need special expertise. You cannot actually download it to your own machine anymore. Generally, science is becoming more and more collaborative, so you want to share results and data. The data sets themselves that people work with are becoming more and more varied. It's not just one table that you can put in an Excel sheet, but it becomes very heterogeneous. And so you need different people who have access and have the knowledge of how to deal with the data. And then what's interesting for this meeting as well is that there's a lot of public data out there that people are interested in. And how do you retrieve that data? How do you handle it? How do you combine it? So IDEIES has built a tool called SciServer, which is a science platform that we believe can help in this effort. And we have some proof that this can help. And so one of the things that we would like to do is see if we can explore some more, because we've been mainly focusing on, say, the harder sciences, astronomy, physics, etc. But we would really like to start learning how can we help social scientists as well, for example. SciServer has a history. Really, the origin was in the Sloan Digital Sky Survey, which was a large astronomical survey of the whole sky. And here, Alex and his team, they basically pioneered putting the data catalogs of objects on the sky in a relational database and allowing people to query this using still the somewhat traditional tools, like also having some web pages where you can browse through the data and visualize it. But most of the work and the interesting part was really allowing people to actually run custom SQL queries against a database. A related effort is something that Charles Manifold will talk about later, maybe, was a database for turbulence simulations that Charles's group and collaborators created, and they had alternative ways, again, also using database technology to allow people to query that without having to download tens of terabytes of data, but actually focus on interesting points. SciServer expanded on this using a grant from the NSF to actually build a tool that expanded both the functionality and the data sets. So in functionality, we allow people to come to our platform, which is all online. They get storage space, they have access to large-scale data sets, no longer only in a relational database, but also as files. They can collaborate, they can create groups, invite people to their groups, and share the access to private data sets or to their scripts. And also using new technologies such as Jupyter and Docker, we allow people to run sophisticated analysis scripts, just full-fledged programming server-side. So because of this, we can actually support many more different data types. For example, images that you don't normally store in a relational database. So these are the images from the Sloan Digital Sky Survey that were underlying these catalogs. We have also cosmological simulations of almost a petabyte of particle data that people can analyze massively parallel. Full data sets of billion particles each are accessible. Another important part also was to expand to other disciplines, and a nice result of this was recently published in The Economist. This is work that Alex did with two of our developers, Dimitri and Sahil, to basically almost do for, in this case, cancer imaging, the same as what they had done for the catalogs of the universe. So isolate and put cancer cells and other cells in a database, allowing it to query zooming back and forth over the image. It's a beautiful application there. But so one of the things that we did also by going to other disciplines, we very often started working with groups that actually wanted to use public data. So here are a couple of examples that we found that can all be handled on SciServer. All of these are using Jupyter notebooks, written Python code that actually retrieves data, visualizes it, or analyzes it. Now, so public data here is, for example, schools districts and crime. This is something where we did some work together with Mark Stein and his group, and Kurt Chronister, who will talk later on. We're listening to GTFS streams that gives the locations of buses real time. There's a project with Sarah Jadan from Etapa where we download imagery from NAPE. The census data that we can download and analyze, store in a database, and create, for example, social vulnerability indexes like the CDC has defined. Census also has the Tiger information about roads, etc. And recently we've done some work with people at NIST about who are interested in analyzing the results of hurricanes, or charged with this sometimes. So the National Hurricane Center, for example, has lots of data available for free as well. So one thing that is for us from IDIES, the original projects that we had, like the Sloan Digital Sky Survey and Turbulence, were created by us, or well, before I joined the group. But so we know what the data is, we know what the science was, and also it was relatively straightforward. Public data is different, and for us, public basically means anything that you could, in principle, download online. Doesn't necessarily need to be free. It might be commercial data, like from Zillow or Twitter. You may need to register, but in principle, it's somewhere out there. And the real tricky part is that generally it was not created for some specific science goal. Now, like census data, it has a goal, but it's not the science maybe that we want to do. And so therefore, to be able to do something with the data, we have to download it. But then we may have to put the data in a certain form that we can use with like a database or somewhere else. And then if we want to start combining the data, it becomes even trickier. For us from IDEAS also, we don't have many domain experts nearby in the field of social science, so that's another problem. So some examples that we already had on our invitation of public data sets that we know people have used are like census, weather, what you see here, and people who might be interested in this, people who work on climate change, or as I said, from NIST, who investigate the results of hurricanes, people from business who want to analyze social networks, etc. So what we are interested in is we want to, as IDEAS, and potentially also with SciServer, we want to see how can we actually potentially help. IDEAS has order of 10 petabytes of storage space available. We have a data center where we can put more storage if necessary. We have compute servers. We have sysadmins who basically using economies of scale can handle easily adding another 100 terabytes of storage. Through SciServer, we have our analysis environment and our sharing environment. So if people put their data inside of SciServer in our data center from IDEAS, we can basically easily share it. And we've got a lot of experience now with disseminating of the derived results. So the problems that we have is which data sets should we get? People should tell us what are they interested in. And then in particular, what we're interested in here as part of the discussion, I hope, is can we find out which data sets we could potentially download, put in our data center, make it available, and have a large number of people or of researchers be interested in it. What this requires is curation. No, we can curate the data sets that we create ourselves, but for these other data sets, we need to have special curation, and this might be actually one of the roles the library can play. And then there is issues of funding. How do we pay for this work? So IDEAS itself can participate in proposals. We've done it a lot for some projects, like Charles recently got I think a 4 million project funded, and IDEAS is playing a role in that. But also through some of our administrators, and we also can help in actually coming up with new funding proposals and navigate all these pathways. So I will end here. So what we hoped from the IDEAS point of view to get out of this is input from you. If not now, then later, please feel free to contact us. But so how might we help get, and at this point in time, with what public data sets are you interested in, and how can we help make those available to you? Thank you. So I'll hand over to Mara. Are you able to share?
I think so. Let me give it a go. Caroline, can you confirm I have permission to share?
Yes, you have permission.
Okay. Can you, I'm not seeing the option. Oh, here it is. I found it. Sorry.
You're fine.
Thanks. Thanks for everybody's patience. I'm just gonna go to presentation mode. All right, how does that look?
Looks great.
Good, good, thanks. So thanks so much for having me here today. I'm Mara Blake. I'm the manager of data services, and I'm excited to tell you a little bit about what our unit does and how we might work with you or work with IDEAS. So JHU Data Services is based in the Sheridan libraries, and we offer a variety of services throughout a research lifecycle to help our affiliates find, use, manage, visualize, and share data. So I'm going to share some details of what those service areas mean to us, which I think has some similarities to the previous presentation, and give a little more details. Before I jump into that, I wanted to share some information about our team. You can see everybody here. So these are the experts who work in data services. We have 4 staff members who work as data management consultants, helping people manage, share, and curate data. We've got 4 folks working with specialty in GIS, geospatial data, and maps, and a final staff person who really focuses on finding and accessing numeric data and visualizing data as well. So the first area that I mentioned, finding and accessing data, the things that we can help with this are strategies for finding openly available data sets from all sorts of sources. You saw several examples of openly available data sets, so we can offer guidance and consultation on where you might track down those data sets and how you might get access to them. We also license several data sets that would not necessarily be considered open in all cases. They're data sets that require some sort of agreement to give affiliates access. They require payment and the university to sign the license. So that's something that we do to make sure people have access. And then we can also help where the data set might be openly available in that it doesn't have a cost, but it requires some sort of special agreement or special restricted accommodations in terms of a physical space. So that's something we can help with as well. Once someone's found a data set, there are lots of different things they might want to do with it. Perhaps working in SciServer, but we offer some services to help build up skills that might be relevant for working with data. One of those areas is especially around GIS and maps. You saw we had a number of staff devoted to this. So this might be finding that openly available data and doing what needs to be done to import it into this specialized geospatial software, getting access to that software to work with the data, working with our collection of maps, which everything that's out of copyright is available digitally and openly from the library on our website. And we also provide access to the Esri education license, which offers us a suite of both online and desktop GIS softwares. We also support computational research and coding. We heard a lot about Python in the last presentation. So if you are interested in using SciServer and want to build up some Python skills, that's something we can offer support for getting started with. We particularly support R and Python with sort of an emphasis on open source tools. And that if you're interested in statistical consulting, we refer to Bryce Corrigan and Agora. I think Bryce is here. So Bryce, you can wave hi in the chat if you are here and feel like doing that. Visualizing data is something that a lot of people want to do once they found a data set as well, both to understand the data themselves or perhaps to communicate the findings of that data or the relevant pieces of that data to an external audience. So we can help getting started with understanding the best practices in visualization or implementing those visualizations in different tools, particularly R and Python, but a couple others, and also help for if you want to create sort of an interactive web-based application. We also offer support for managing data. So we heard about grant proposals last time, so something we can offer help with in consulting are preparing data management plans that are part of grant requirements in many cases. And one way we can help with that is through the DMP tool, which is a web-based interface for creating a data management plan. And then once that planning part is set up, we can also help with implementing whatever those best practices for managing data in research workflows are. In addition to helping people work with existing openly available data, we can also help people share their own data to make it openly available. There are lots of options to share data, so we can help sort of navigate the different options and evaluate them. And this can include advice on preparing the data for sharing so that it's documented so that someone else could reuse it. Same thing with code. That also might include some advice on human subject considerations or de-identification considerations for the data. And one option for archiving data is the JHU data archive. And so we have folks who put data in this archive, often to comply with funder requirements or with publication requirements. And it's a JHU branded open access data repository. So everything in here is fully openly available. And so one of our consultants helps the folks who want to deposit their data here. So that's one option we provide as well. If you're interested in any of these areas, there are some different ways to connect with us at Data Services. One way is through our series of workshops. So we offer a really robust workshop program in all the areas I just described. There's a series of open workshops. If you want to get started, any JHU affiliate can register and take those workshops, and they're geared primarily towards an introductory and intermediate audience. So they're a great way to get started. We can also do customized presentations for classes or research groups if there's something specific they want to learn. And also on our website, there are a series of online modules that can be taken at a self-paced kind of anytime way. We can also do consultations on these topics. Right now, they're email or Zoom based, not in person. And that, again, can be for an individual researcher or for a research team. And our website has a collection of guides and resources on these topics as well for reference. And so we'd really love to hear from you. If you're interested in reaching out to us, you can visit our website, which is listed here, or contact us via email. And so, we'd really welcome any contact from you that you're interested in having. So thanks so much for having me here today, and I'm looking forward to learning more. Thanks.
Thank you, Mara. And so we'll move on to deep dive research presentations. And for this segment, we're going to have two scholars present their research and also illustrate how they utilize public data sets to achieve their research objectives. Our first speaker here is Professor Andrew Ching, and I'll have a really quick introduction to Andrew. So Andrew is my colleague at Carey Business School, and he's a professor of marketing, but he's also a professor of economics at the economics department and also public health at Bloomberg School of Public Health. So his research focuses on developing new empirical structure models and estimation methods to understand the forward-looking strategic learning and bounded rational behavior of consumers and firms and the complicated environments. So his talk is going to look at consumption response to an unpopular policy. And Andrew, I think feel free to share your slides.
Thank you very much, Tinglong, for your introduction. And I really appreciate this opportunity to share my research with you, and I have an opportunity to get to know the colleagues at other departments better. Can everyone see my slide? Right? Okay, good. So I'm going to jump right in. So this is a paper about how consumers respond to certain policies that we deem it as unpopular. That is, majority of people do not agree with this policy. And how do they respond differently compared with the people who agree with it? Okay, and we're going to use an example of short-lived solar tax in Washington State to illustrate this. So let me just motivate this research question, and then I will tell you a bit more about how we use different data sources to answer our research question. So the one motivating us to look at this problem is really something, I think quite easy to be related to if you think about what we experienced in the past 14 months during this pandemic. We have policies on social distancing, mask mandates, and things like that. These policies, in some sense, they restricting consumer choice, intervening our choices for the greater good. In this case, mask mandate is for public health. In other situations like soda tax, it's also about public health because soda is an unhealthy food product. And when people consume it too much, it creates health problems and impose cost on the economy that we need to treat them. Energy is another example. Clean energy, we see government try to use different incentives to get people to use clean energy. So all these kind of policies are kind of what we're thinking. And in particular, in this paper, we're going to examine soda tax. And as you can imagine, things like social distancing and mask mandate is very controversial. There are people who agree with it. There are a lot of people who disagree with it too. And we see that people who disagree with this policy, now they do not necessarily disagree in the sense of they don't think we should care about public health, but they don't like the government restrict us, have policy to impose and force us to do something. Right, and as you can imagine, when that happens, they might actually have some kind of rebellion behavior. Some people deliberately don't wear a mask or don't social distance just to show that they disagree with the policy, they disagree the way it's implemented. So past research has very limited, it's quite limited in terms of studying how to what extent people agree with this policy or disagree with the policy might affect the way they respond to it. Okay, there's some existing research look at it, but only very handful. And the way they do it is basically just use party affiliations as a proxy for whether people agree with that policy or not. Right, so the people will use if you're Republican, then you're more likely to disagree with the policy, and that may be the best they can do. But we're going to argue that we will be able to do better if we leverage the existing multiple data set publicly available to try to think more creatively. And so this paper is about what else can we do if we want to go after this research question, in addition to just looking at party affiliations, what else can we do? So what we do is in this paper, we look at this very short-lived soda tax in Washington state. And we call it short-lived because the tax was implemented in July 2010, but it was repealed by a referendum in November 2010. And then on December 1st, 2010, the tax was repealed. So it's only lasted for 5 months. And this tax was passed in a very controversial way. It received very little public consultations. It was passed together with a budget, a government budget. And at that time, Washington state is completely controlled by the Democrats. And so they're able to just pass it very quickly. So it received a lot of pushback, and the soda tax manufacturers are able to gather a lot of signatures in a very short time and put this referendum on the ballot in November. And then the public can vote on this referendum. And so what happened is we are actually able to look at the vote outcome for this particular policy. And we can see to what extent people disagree with it. Okay. Now, if we're able to observe each individual vote, right, then that's perfect. If we can see how each person vote on this ballot, and we also can see how they consume soda during the period when the tax is implemented, then we can actually just directly measure whether if you don't agree with this policy, do we see that you actually reduce the consumptions more or the other way? Right. The challenge is that, of course, we don't observe the individual level vote outcome. We only, at best, observe it at the precinct level. Okay. So how can we make use of that data in order to be able to say something about how people behave, how that related to associated with people's behavior? Our solution is, first, we're going to aggregate the precinct level vote data to construct a measure, a variable, what we call tax unpopularity at a retail store level, at a supermarket store level. And then what we're going to do is we're going to also look at data that give us information about at the store level, the sales of different UPC code of the soda during this period, before and after, in fact, before the implementation, also during the implementations period. And then we're going to use difference and difference approach to measure the impact of the stores that have consumers who are more likely disagree with this policy if they the response there differ from the stores that tend to agree with this policy, right, with the consumers. So that's the basic idea. So what we're gonna have a bunch of robustness checks in the paper, but I'm not gonna go through it. I will just make use of my time to focus more on how we actually use the data to construct that tax unpopularity measure at the store level. Okay, but we do find that in our research, in our results, we do find that the stores that has more consumers who disagree with this policy, they tend to reduce their consumptions more. Okay, so it sort of fit our hypothesis that people who disagree with this policy for whatever reasons, they may be more likely that their mindset of rebellion mindset is being triggered, and they try to just potentially just reduce their consumptions as a way to maybe show the public that, or show the government that they don't agree with it and they don't want to share the tax burden. So that's going to be the focus of this research. And so again, a little bit of the background about this policy. I already mentioned this policy was proposed in April 2010. It was passed very quickly. And the purpose is primarily try to close the budget gap. They need more revenue. And so they decided to put some tax on soda. And it was not widely publicized and until basically it's passed. And then the American Beverage Associations quickly get together and collect enough signatures. In fact, the law passed in April and they're able to gather enough signatures in May. It shows that how unpopular this policy is. And when they voted on in November, it turns out that about 60% of the voters choose to repeal this law. So it is quite unpopular policy. The tax is basically 1 cent per 6 ounce. So it's not a whole lot, but it is enough to make some people unhappy. Okay. So let me talk about the data. The outcome variable of our research is going to be the sales and prices as well, but sales is really quantities sales of each UPC code of the soda is the focus. And we're also going to create a cross-sectional store level characteristics, including what type of consumers that shop at this particular store. So you will see that we're able to make use of the data from Nielsen. AC Nielsen is a marketing research company, and they actually have made their data available to the academics to do academic research. And as far as I know, our library has also subscribed the database. And so it is available to Hopkins community. And we're going to make use of two data sets to address this research question. One is called retail scanner data. So this retail scanner data is at the store level data. It tells us for each UPC code what's the sales each week and what prices that UPC code is priced at, and also tells us some promotional variables. It also tells us roughly the location of the store, and another data set which we also make use of is called home scan consumer panel. And so this is a data set that is tracked individual consumers at the household level. It's a longitudinal panel data, and it has something like 400,000 consumers for the whole country. At a high level, what we're going to do is we're going to make use of this data set to help us to create the spatial composition of consumers at the store level. Okay, so what we can tell from this data set is basically a shopping trips data. We know the consumers what they bought in each shopping trip. This is what they're required to do. You know, if they are in this panel, every shopping trip you make, you need to file a report and tell nuisance about which store you went to and what items you purchased and at what prices. And so the shopping trips data allows to tell us that the consumer's address and also tell us which particular store they go to do shopping. And so we are able to use this shopping trips data to basically create a composition of consumers that go to this particular store. And so roughly speaking, how do we create these unpopularity measures about this particular tax? Now we have the precinct level voting data, right? And so first of all, what we're going to do is we're going to aggregate this precinct level voting data to the zip code level, okay? Because what we have about this consumer panel data is the zip code address for the consumer. We don't have the exact address, but we know the zip code. Okay, and then we're gonna, from there, you know, we have the vote data at the zip code level. Now we can basically, based on the shopping trips data and the spatial compositions data at each store that we created, and use that to help us to aggregate it again to obtain a store level vote share data. Okay, and that vote is going to reflect you know, to what degree that people support the repeal of this particular soda tax. Okay. So once again, you know, we're going to use individual voting data aggregated up to the zip code level. Now I want to emphasize the ballot, the way it's being structured is if you vote yes, that means you want to repeal the soda tax. Okay, if you vote no, that means you want to keep it. So the store level data is essentially we weighted based on the news and consumer panel data, and the zip code that you know, where the consumers come from is going to be weighted again by the share of the dollar spent on that zip code. So we have these unpopularity measures, and sometimes I'm going to interchangeably use it together with the support of repeal. Now this measure, you know, because it goes through a few aggregation steps, right? So it's going to have some noise in there. So in order to sort of help us avoid the noise, what we're going to do is we're only going to look at the stores that are on the top 30 percentile. We're going to call those stores as stores that they support repeal, they tend to support repeal with consumers. And the bottom 30 percentile are the ones that we're going to code it as 0. That is, they tend to be the consumers who want to keep the soda tax. And so we're going to sort of look at these two extreme type of stores and see if we can detect any significant differences in terms of the consumption response to this policy, to this soda tax. We're going to have other control variables as well, like income and other household characteristics at the zip code level, where we get it from American Community Survey. And so basically, I would say that the key data sources that we use come from 3 different data sets. One is the precinct level voting data, which is publicly available. And then the other 2 data sets is from AC Nielsen, their home scan consumer panel data, and also their retail scanner data at the store level. Okay, so all this data are publicly available, and I will be happy to answer questions at the end if anyone wants to know more about that. So after we have created this measure at the store level in the Washington state, we're going to use this difference in difference approach, and now we need to find control stores, and the way we do it is we're going to look at neighbor states, because what happened is this tax is imposed universally at every retail store in Washington state. So in order to find a control store, we need to go to neighboring states. So we look at neighboring states like Oregon, Idaho, and Northern California, and try to find a supermarket that has the same observable characteristics and match it with a store in the Washington state. And so I'm going to skip these detailed things, but here is one picture about Washington state, about the way we code which store is support repeal of the soda tax, which store against the repeal, that is they tend to want to keep it. So you see there's some concentrations over here for the stores that tend to against repeal, that is they're for the tax. This is Seattle, okay? And there are another sort of a cluster here. This is Spokane in Washington state. And then in the rural area, you can see most of the stores are support repeal. They want this tax to be gone. And this, I think it passes the first test, sort of common sense test. This is what you expect. The stores that are more concentrated in the city, they tend to be more liberal, the consumers there. And they tend to agree with this soda tax. So we also want to just show you these pictures that compare the stores that support repeals and the store that against repeal. And you can see quite strikingly, when you look at the difference, you can see the stores support repealing the tax, that they want the tax to be gone. Their consumption drops quite significantly, okay? Quite a bit more than the stores that are against the repeal. Now for the price, the price pass-through actually is about the same for both type of stores. So you cannot use price differences to explain this. And so our difference in difference approach, most basically is like in this design. So what we will be looking at is beta 2. Beta 2 is capturing the effect of the stores that want the tax to be gone. They support repealing the tax. Okay, and beta 1 captures the non-supporter stores effect. Okay, and the basic finding is stores with consumer support repeal, we see on average 6.5% reductions in the quantity consumptions. And compared with those who are against the repeal, we also see reduction, but the reduction is only 3.1%. Okay, so you can see it's more than double the response. In terms of pass-through of the tax to the price, it's pretty uniform across stores. Okay. So if you look at the regression result, what you should be looking at is really specification 1 and 4, 2 and 3, 5 and 6 are just robustness checks. We throw in other control variables, but they really don't do anything. They don't even change the R square. And you can see the effect, the coefficient is significant for the beta 2 that I indicated before. And the effect is almost double compared with the stores that are that want the tax to be there. So the people who don't like the tax in those stores, we tend to see that the consumption drops quite a bit more. Now we have done a lot of other robustness checks, but I don't think, given the focus of this seminar is about the data, I don't feel like maybe it's no need to get into all these robust tracks. But we did look at, in addition to the store level, we also look at individual consumers' reactions using a very similar research design. We see that the outcome is also consistent with what we found in the main regression results. And we also look at things like, hey, you know, what would be the key reasons why people reduce their consumption demand? Is it because the demand curve shift, or is it because they tilt, you know, becomes more sensitive to the price? And what we found is in another regressions, which try to tease out the mechanisms a bit more, which is in this research regression design, we basically found that it is due to the shift in the demand. And the consumers who want the tax to be gone, we see a shift inwards of the demand curve. And in fact, in terms of the price response, it becomes a little bit tilted steeper. Actually, less steeper, it actually becomes flatter. So that's also quite interesting. And so I want to make sure that I have leave some time for questions. So I'm gonna just wrap up my presentation here. I'm gonna just give you the bottom line. And what we found is, I think this is one of the first study that used voting data to help us to measure the negative sentiment of consumers towards a policy, and then measure their response to it. You know, we cannot pinpoint exactly what the exact psychological reasons behind it, but it is something that standard economic theory, standard economics model cannot explain. And so they point towards a behavioral mechanism. It could be one of the rebellion theory that I mentioned earlier. Now, interestingly, the soda tax in this case turns out to be, because of this peculiar psychological mechanism that is playing a role, it turns out that it is most effective in cutting down demand for the people who actually want to vote against it, want to overturn it, right? And so in terms of health benefits, you know, what we are thinking is, you know, if we can reduce the demand for this soda, the people can benefit from it in the long run in terms of their health. These people who don't like it potentially can benefit the most. But of course, clearly what we see is that these people also care about other things, right? So maybe in addition to long-term health, they care about the short-term pleasure of drinking soda. They care about the political process, how these law or how these policies being implemented, being passed, or they care about freedom of choice. You know, all of these could be playing a role. So I'm going to stop here, and I can, if still have time, I will be happy to answer questions.
Thank you very much, Andrew. Thank you for your excellent presentation. Really enjoyed it. We do have quite a bit of time. We have, I think, 15 minutes actually. So any questions from the audience? And Carey, I'm not sure. Can people turn on like just?
So if somebody has a question and they'd like to raise their hand, we can enable their mic and they can ask their question.
Oh, sure. Okay. Okay, sounds good. And yeah, so while we, so feel free to raise your questions while we wait. I do have a quick question for Andrew, and I like your broad, I mean, this is very, very nice presentation, very good study, but I'm thinking the general idea of understanding consumption response to unpopular policies. Certainly, as you mentioned at the very beginning, there are a lot of unpopular policies these days. For example, lockdowns are very unpopular. Do you think this framework and also the way you identify and link data sets can be applied to evaluate other unpopular policies?
Yeah, thank you, Tinglong, for this question. I think, you know, I think there is certainly room for us to explore this voting data, right? So because from time to time, there are policies, specific policy being put on the ballot, okay? And so, I mean, I myself have seen it a number of times. And so those individual ballot data are available to the public, right? So you can there are different reasons why that particular policy is being put on the ballot. Sometimes it's not implemented yet, but people want that policy to be implemented. Okay, but sometimes it is exposed. The policy has already been implemented, but then people want to repeal it. And so I certainly think there are potential to look into this. And now the exact to leverage the data that we use from AC Nielsen, now your research questions will have to be related to consumption response to things that people buy in the grocery stores, in the supermarket. But if if you have other things they're thinking, maybe electricity consumptions, you can sort of think of this as a framework, right? You can still go and look at the voting data, and then if you're able to get other data on electricity consumptions, electricity usage data from maybe from an electricity company, and then you can also try to link this data together, right, to answer that kind of questions too. And so so I see this as potentially can be used in not just soda tax but some other policies as well.
Thank you very much. Caroline, do you have people who have raised their hand from the audience?
I do not. If people aren't comfortable asking, they can always drop it in the chat, or there's also a Q&A panel as well. So whatever people are comfortable with.
Sounds good. I actually have another question here. It's about the soda tax effective, like second idea in cutting down the demand for those who wish to overturn. I think there are two ways of thinking about this. One way is that the reading is effective in this group because this group is going to be effective. Who really care about it, right? So if someone does not consume a lot of soda, probably they do not care so much. The other way of interpreting this could be that is because of certain kind of socioeconomic factors that actually specifically connect to this group that make them more sensitive. So they're more likely to oppose it. Because if you ask anyone whether they like to pay more for something, even if it's something not necessarily pleasant, in general, people want to pay less for something, right? Is that something your data can speak to?
Yeah, so I can tell you the following. Now, because this policy was passed very in a rushed way, and so during that period of time, as you can see, it only took the beverage association 1 month to get enough signatures to overturn or to put these things in the ballot, and so they did a big campaign during that period to try to educate the public that this is policies there, the soda tax is coming, and it's not they didn't consult you and things like that, and so I think a lot of people are aware of it, and the vote turnout is 70% of the population went to vote in that November elections. So it tells us that the vote turnout is not bad. It's actually quite good, and so in that sense, we feel that it's not necessarily that people who care more and they go and vote. Now this is not just this ballot; it's the November elections, right? It's just one of the things that they will vote together with a bunch of other things. Like there's some seats that are available at the state level. They have to vote those things too, and so we feel that at least on the vote side, it's not going to have a selection issues there, or very, very little selection issues there. I don't know if that answers your question.
Yeah, no, that's very good. Actually, related to your answer, we actually have a question from the audience, a Q&A function. I think it's Eric, Ms. Chang, and the question is, sorry if I missed it, but did you connect these results to income data and the volume? Even though the tax is small, could the relative cost more proportionally affect those who want to repeal?
Yeah, very good question. And we did, yeah. So we did control for income, right? If you look at that regressions that we have, these are income variables here. Okay, if you see my hand, the circling did not, and they are basically hardly significant. Yeah, so now actually not this regression. Now I should move to this one here. And so, yeah, so we did look at income. They're not significant. And we're not alone. There are quite a few other studies that they don't look at the negative sentiments. They just look at the effect of solar tax. They also control for income, household size, and other things that they can collect publicly available, and that's consistent with what we found. They just don't have any explanatory power. Yeah.
So is that the income data like individual level or more like that?
So the income data is collected. I will just turn back here to talk about the data a little bit. And this is also data that one can use easily. So there is from American Community Survey. So it is at the zip code level, okay, not at individual level. Okay, so at the zip code level, you can find average or medium income, and average or medium household size, and something like that. Okay. And so we go through the similar procedures to aggregate from the zip code level based on the shopping trips data to that allow us to create these spatial compositions data, consumer spatial composition at the store level, and then we use that to obtain the income information at the store level. Yeah, so I hope that answered the question.
Yeah, so do we have any other questions? Also, I know, Andrew, you are actually attending a conference. Really appreciate your juggling between the conference and the workshop. And yeah, I understand you actually have a talk. You're giving a talk very soon, right?
Yes, I need to give I need to discuss a paper.
Okay.
Yeah, this afternoon. Yeah.
And yes, if we don't have other questions, really appreciate your taking time to present your research, share your experience and perspective with the rest of us. And thank you very much. And
thank you, Tinglong, and thank you. Thanks everyone, and thanks Caroline for organizing everything. And I would just say, this data, home scan data and retail scanner data, they are available to the Hopkins community, and it's very rich data, and it has basically anything that you can see at a supermarket. Those items you can find it there, and so not just soda, but other things, and people even look at like cigarette consumptions and things like that before. So if your research is related to cigarette consumption, for example, this can be a data set to look at as well. Or some others as consumer packaged goods in general, if you're interested in those questions. And so, great. So thank you. Thanks, Tinglong. And if I really hope I will have more chances to interact with the colleagues here in the future.
Thank you. We look forward to that. Thank you, Andrew.
Okay, thank you.
Now we'll move on to Gerard, and Gerard is going to introduce our next speaker.
Yes, hi. I'm going to introduce Kurt Chronister shortly. Kurt is the Senior Data Manager for BERC, the Baltimore Education Research Consortium. In development of SciServer, we had quite some interaction with them because they provided some interesting use cases for us that were very different from the usual ones, as I mentioned earlier on. Particularly, they had lots of questions where public data was interesting, and we learned that with our new system that we had built, we could actually quite efficiently retrieve such data sets and massage them, etc. So we've also had plans to continue this in using grant proposals. But one of the tricky parts is that lots of the the data that they would like to use from the School of Education requires data about students, which requires much more security than we always had to provide for galaxy data, for example, astronomy data. But about CURT itself, so Jim Gray, who worked a lot at IDIES, he said that people that we should aim for to try to help are people who are desperate, who really need our help. But I don't think that people who work with CURT need to be that desperate. He's got 20 years of data management experience. He had all the database experience that we thought that we could bring in new. Nevertheless, it's been very interesting working with them, and he's provided scripts for downloading and massaging data that we've been using directly in our systems. And so we're actually very interested to hear his experience, and he's going to talk about what, when, where is a school. So please, Kurt, go ahead.
Thank you. Can you hear me okay?
Yes, I can.
Yes, yes.
Okay, can you see that?
Yep, looks good.
Okay, great. So hello, everybody, and thank you for meeting today. My talk today is about using public data to contextualize schools and educational research. As Gerard had said, I work with the Baltimore Education Research Consortium, and we are a research practitioner partnership between the city of Baltimore, the school system of the city of Baltimore, and 11 consortium member universities. And we do research to improve the educational and life outcomes of children in Baltimore. So Burke uses quite a wide variety of public data sources for educational research. And what you see in front of you, it varies very greatly in quality, in quantity, and in the ability to use it in a longitudinal manner. And so starting with the top row here, the NCES, and I'll talk more about these data sets later, but this first one is a federal data set, and it goes back, I think, 30 years. It has very detailed information about public schools all over the country. It's all in the same format. It's easy to download, and it is also, once it's on that database, it stays there. The same is true for the MD Report Card site, which is State of Maryland's Department of Education site, which publishes test scores and attendance rates and things like that. And it is additive. And so as a new year of data is added, the rest of the data stays there. Of course, the same is true of the census data. Once it's on the website, it's pretty much there forever. Now, a lot of these other things, you can't say that. Schools lists that appear on the Baltimore school system website, they're refreshed year to year because they're mostly concerned about what's happening currently. And they don't necessarily have an archive going back for years. And so that's also true for, and I'll talk about it later, the Comprehensive Facilities Master Plan. It is a rich source of information, 400 or 500 pages long, has tons of stuff in there that's good, but every year the new one gets put up and it's very difficult to find old ones. And that is a real problem for someone expecting to say like, well, I'm going to do 5 years of longitudinal research. I can't find the document that I need. And so we're going to talk about those problems. In addition to a lot of spatial information data, this transit data that Gerard's team is actually storing for us that he alluded to, this is so transient that it changes every 10 seconds. And they do not have an archive readily available for you to query. And so we decided we wanted to collect it every 10 seconds of the day to see. This is an extremely rich data set on the real-time position of buses and where they're going and where they've been and all the history. Talk about transient. This is the most ephemeral data set that you could imagine. And because when you do start to store it, it's massive amounts of storage that you need. And the other part of, that I want to talk about is property maps, school zone maps, neighborhood maps. There are some public sources for these things, but there are times when it's difficult to ascertain the provenance, as well as it could disappear tomorrow because there's not necessarily a curated place for these items to sit and for someone to actually check them out and say, is this valid? Is this a valid thing? So I'm going to start really at the top here with these school-specific data sets. So at the federal level, the National Center for Educational Statistics makes this CCD data set available for download. And there is an interface on top of it called the Elementary Secondary Information System. And as you see below here, the one on the right allows you to do very precise choosing your fields, choosing the years that you want. It's very extensive and very easy to use, and we do use it quite a lot. And it's aggregated at the school by year level, and it goes back, like I said, in some instances, I think to the 80s. At the state level, and I assume that other states have a means of reporting results from standardized tests and things like that. Maryland State Department of Education has a particularly good website called MD Report Card. There's a variety of school level data sets, some of which you can see down here, having to do with attendance and test taking, college readiness, graduation rates. The NCES data, as well as the MD Report Card data, share the important feature of they're easy to link because they provide all kinds of different identifiers, including the one that local school districts use. And so when MD Report Card says this is school number 250, there's a version of that in the NCES data set that makes it very easy to link things together. And that's critical, as we'll see later. And then at the district level, Baltimore City Public Schools website has a lot of useful information on it. We find particularly useful, they have a yearly school directory that's a little bit hard to find, but we go there once a year to grab this data set. You can Google a lot of the information that's in this document, phone numbers, addresses, bell times, not so easy to get, but it's the only place that I've seen that has all of that information in a single place. And so that makes it extremely valuable. And it comes from the district. And so it has been vetted by them, and you can trust that it's good. So these data sets that I've talked about so far are kind of the direct measuring of the district and the students. And they're the obvious places that you want to start if you're going to do educational research with public sources. But there are external factors that you want to be able to gather and to consider to contextualize this other internal data that you just found. And one of these sources is census data. It's an extremely rich source of data going back many years, extremely wide and detailed data set. And increasingly, because of additions to packages in the R and Python languages, you can before you had to download a data set and kind of process it yourself and store it. But now just in the middle of your code, you can very easily say, I want the incomes for everybody in this zip code from 2005, and it's right there for you. It's very, very easy using API calls. The one thing though about this data is that you have to make a lot of decisions about the time element. So, if you're doing a research study in 2011 and the 2010 census has just been finished, you might as well use the 2010 census because it's not only current, but because of the sampling, it's way more precise. But in order to fill the gaps, the American Community Survey is done every year, and they aggregate 1, 3, and 5-year estimates. But there's various trade-offs with how current it is and how precise it is because the sampling rate is so much lower. And so those are important considerations when you're choosing which kind of tool to be using, as well as the fact that since the majority of schools in the country start in September of one year and go to May or June of the following year, it's not completely obvious which year census data that you would want to use. in order to contextualize things about the school and the students. And so how might we use census data to characterize schools? The simplest method would be to just spatially join a census tract map with a point file of schools, which is just to say overlay the school map with the census map and say wherever census tract that school lands, we're going to load the characteristics from the census onto that school from the tract. And so in this example I have on the screen, these three schools, 28, 322, and 107, would all take their census values from this tract. But of course, it's not so easy. And the reason is because of school zones. Most cities have catchment areas for schools that say, if you live in this area, you need to go to a specific school. So just to show how these don't match up very well, here's the 2010 census tract map and the 2016 elementary zone map. And the map on the right overlays them and shows that although there are some coincidental boundaries that match, for the most part, it really doesn't match at all. So looking more specifically at the schools that we were looking at before, you can see school 28. Previously, we're just going to assign the characteristics from this one census tract. But as you can see here, the zone, the catchment area for school 28, has portions from 4 separate census tracts. And for school 107, you can see that it touches 1, 2, 3, 4, 5, 6 different census tracts. So what do you do about that? So one possible solution, and that's commonly used, is to create weighted averages of the census values according to the proportion of each tract that's being overlapped by the school zone. And this is not something that you have to do in a custom manner. Usually there are tools in GIS software that can understand what you're trying to do because it's aware of what the area of these spaces are. And people use that kind of calculation all the time. One thing that overlooks, though, is that it's making an assumption that residents of a census tract are uniformly spatially distributed, which is almost never the case. There's sections of a census tract that have only people in one corner of it or just on one side. So the way to, so what you're doing is you're accounting, we have to find a way to account for the fact that people are not evenly spatially distributed. Non-residential spaces are scattered across the city. And as you can see in Baltimore specifically, a lot of industrial areas are centered around the harbor and on the east side, as well as very large green spaces in the middle of the cities and along the arteries of the cities. These kinds of shape files to distinguish residential from non-residential can be found often on city or state planning websites, as well as the state property tax parcel shape files. They all distinguish between these kinds of land use. And so one thing you can do is to figure out where these spaces are and kind of subtract them from the census map. So what you're left with is a more accurate view of where the people are actually living in those census tracts. And then when you go, and so here, zooming back in on the schools, all these shaded areas are places where people don't live. And if you subtract these areas, in some cases, entire census tract portions will fall out. And so looking at this school zone right here for school zone 107, previously you would say that it shared some space with this census tract. But once you realize that nobody lives there, you don't have to worry about this one at all in your calculations. And so this is just to say there's a way of being more accurate with how you're calculating your weighted averages using the census data. So other caveats for using the zone maps, there are many. In Baltimore, only elementary schools are zoned. Middle schools and high schools use a choice system, and so their enrollment patterns are way more scattered and expansive. There are also many charter elementary schools which don't have a fixed enrollment in zone. They are responsible for finding their own facilities to operate in. And so using census tracts is likely not a valid approach for approximating student characteristics. And going back to a previous slide, this school, 322, is in fact a charter school. And although it would be tempting to use similar census variables on all these schools, it's likely that these students are coming from further away. There's also the fact that finding zone maps online is not easy, and often they lack sufficient or any documentation except for the title. And one thing to consider, if we found this map online next to two perfectly valid current maps of school zones, and it's called BCPS middle school boundaries. It's unclear what that means because middle schools in Baltimore do not have zones. And so, and if you look in particular at the green zone in this map, it has a school ID embedded in the map file that we have never seen before, as well as the fact that this would certainly be the hugest school zone you've ever seen in your life, and also quite ornate. So the rest of the map seems to aggregate elementary zones, which makes us think that this document might have some kind of historical significance or some kind of a summary of what elementary schools, typically the feeder patterns are into middle schools, but it doesn't say. And the problem, if you stumbled across this map next to these other good maps, you might be excused for thinking that this is valid. But we've been looking at these kinds of maps for a long time and we don't know what this is. And so, which is all just to say, finding these things online is difficult, and knowing what they mean can be even more difficult because of the lack of curation and also of supplemental information about them. So to continue with zones, another thing to know is that in a large city that's growing and shrinking in different parts, the portfolio of schools and school zones is constantly changing. As an example of that, the Baltimore elementary zone map has changed every single year from 2016 to 2021. And oftentimes a change in the map it can be attributed to a single zone school that's closing, which causes the surrounding schools to absorb the students as well as the geography of the zone. It's also good to keep in mind that schools also move. When schools are renovated, the students might be using a different building, and it's not necessarily next door or across the street. It can be across town, and then they might return the following year. And charter schools, since they don't have a set zone, are also freer to move around than other schools. And this goes back to what I was saying about some of these data sets that you find are ephemeral, and these moves, there's nothing to say that a renovation takes a full year. It might take 6 months. And so if you're doing the kind of research where it's important to, for instance, for transit, if it's important to know that at the beginning and for the first semester, this school was on this side of town and the second semester on that side of town, it's very difficult to be sure that you're finding the correct source in time that proves those things. So our organization, Burke, pays very close attention to details like these school moves. But because it's kind of slippery business keeping track of all of them, we occasionally miss one of them. And an example of that is the Maritime Industry Academy in September 2015 moved literally across town from the northeast corner of the city to the southwest corner of the city, 9 miles, which is about the longest distance you can go in Baltimore. At the time, we were working on a transit project that was estimating travel times to high schools from various points in the city. And so we simply missed it because we were using a map from last year when we should have been using the current year. And again, part of that is because there's no one really good public source where you can find things like this. So, to summarize all this, using school zones can certainly be very helpful, and depending on the city and the availability of quality maps, but a lot of care has to be taken to ensure accuracy and also timeliness. So to give another example of using public data to talk about the where question, and also when in this case, sometimes providing context for schools, you need more detail. And so we're currently involved in a project that is looking for links between facilities conditions, the conditions of the buildings, and student outcomes. In order to accomplish this, we're using data from a report that was completed in 2011 called the Jacobs Report. It's extremely detailed, and it assessed the facilities conditions of every building in the Baltimore City public school system in 2011. The Jacobs Report, most of the report is a discussion of methodologies of how they came to rate these schools. They have two important scores here called the Facilities Condition Index, as well as the Education Suitability Score. And so we wanted to collect those for each school, and again, connect them eventually to student outcomes. And so they have appendices at the end of the report that show this data. Well, there are two problems. Is you have to get the data out of the PDF, so it's not in a great format. And then you have to figure out what this number column is. It's not saying it's a building number. It's not saying it's a school number. It just says number. So the first problem was how to get the data out of the report. So if you tried to cut and paste tables from a PDF, there are certain kinds of data that will work better than others. This kind of data does not work particularly well because there's no uniform delimiter across the columns. And so if you tried to delimit by spaces, it would catch the spaces in the campus name. It would also catch spaces that are in the table that, or spaces in between the $ and the amount. So what you actually have to do for something like this is cut and paste these collections of data and then kind of you have to move around every single value until it looks right, which is fine. There were a couple of hundred rows to deal with in this report, which is fine. It's a one-time situation and then it's done. But of course, there's a lot of there's a lot of very precise values here. So we had to check and double check all those things. And then we had to figure out what this number column was. It turns out it was a school code unless it wasn't. If the school was in a building that had the same number, then it matched our records of school numbers. But if it was not a school number, it was a building number. And we have never worked with building numbers before. And so we didn't initially understand this problem. Once we figured out it was a building number, then the task was to figure out, well, where is that building? The campus name could sometimes be used to identify the school, but a lot of times the number just had the building name and not the campus, not the school name, as well as the fact that there are some building complexes in the city schools portfolio that have multiple schools that are using the same building at any given time. For instance, during a renovation, they might use it as a temporary space and then move back into a permanent space afterwards. So what to do? So we had to find a source that connected a building number to an actual address. And harder than you would think in time. You could find a current list of addresses, but what about going back 10 years? And so what eventually we were able to come across is a document called the 10-year plan for Baltimore City Public Schools. This was a great document that was highly detailed. It referenced the Jacobs Report directly, which was a big help. And then it had a little vignette about each school. And in that vignette, it had the school identifier, a building number if it differed from the school identifier, and an actual address where it was at. And so finally, we had that connection between address and building number that we needed. Similar information was also found in the Comprehensive Educational Facilities Master Plan from 2018-19. But the problem was some schools and buildings had since been closed. And so this report was too new to be to use as an accurate concordance for 2011. And this is the problem with some reports like this, is that, again, like some of the other reports I've mentioned, it's extremely comprehensive, 300-400 pages. It has lots of lists and tables and details about each school. The problem, again, is it's in a PDF. And so if you want to get that data out, it's not always easy to do. And also every year, the newest document comes out, and it's unlikely that the old document still exists. And so this is another area where if we had a curated collection of these facilities master plans, which are all public documents, it would go a long way to making longitudinal type research much easier. And so with the new data set that we found in this report, we were finally able to match the facilities index to the school. And this just goes to show how there's no one data source that's ever going to be the one that you need to do everything. So I was able to use the Jacobs report to go from the facility conditions index to the building number, using the tenure report to connect building number to address, using the federal database to connect the address to a given school in a given year, and then finally take the step of a school in a given year you can match to student outcomes by looking in the MD report card website. All this just to say, we thought that this was going to be easy. We thought that this Jacobs report already could connect us directly to student outcomes. And it really took us on a journey. Not only are these public data sets, but this was data that actually couldn't be gathered in private data sets. And so we needed these data sets to be where they were. And so this one worked out. So I want to thank everybody for listening today. I could talk about, I'm doing this kind of work all day. And so I could talk about this stuff for a long time, and I'd love to hear questions that you have, or you could also contact me at the email address below. Thank you.
Thank you. Thank you, Kurt. If people have questions, they can put them in the question and answer. Or
Right.
maybe the chat. Said?
Yeah, I have a question, Gerard. So first, Kurt, thank you for that presentation, and I just want to applaud you for your perseverance, I guess. It seems like the forensics or detective work, I don't know the right term, is really quite impressive. The question I was going to ask you is about this, I think you called it master facilities plan and having an archive of those reports. When you talked about that, did you mean having the reports themselves, or the data within the reports, or both? Just a little bit more about what you meant about having an archive of those reports.
I mean, ideally, well, I'll say that if it's in a PDF and I can see it, it's at least not lost. It just takes an extra step of work to format the data into a shape that's queryable, basically. Now, it would be extremely helpful if there were tabular data sets that were the same in every year. I'm not sure that they organize it in exactly the same way every time, but it would certainly be helpful in the case of large public data sets that end up being published as PDFs, if there was some way to make supplements that, if there is a table of any kind in there, that there's a version of it that is more easily linkable. And so I think that, and some of it's not that much work, right? For the Jacobs report, it took about 30 minutes to an hour to make that conversion. When it came to do the 10-year plan, that took a couple of hours because it wasn't in any tabular format at all. I had to cut and paste every page of like a 200-page thing. But the good news is, once it was done, it was done. There are some lists, though, that if you're talking about doing 10, 20 years of longitudinal research, it's a high barrier and an unnecessary one, probably, because whoever made that report of the PDF was just PDFing an Excel sheet. And I get that we're asking for a lot here, but it would be nice to be able to have that kind of modularity to those reports. But yeah, I hope that answers your question.
Yeah, very much. That's very helpful. Thank you.
Any other questions from others? So I have one. Oh, Charles, go ahead.
Yeah, Kurt. Yeah, very, very interesting. I was curious, did you ever have to contact actual people who may have been authors of these reports, or did you rely, as a matter of sort of method, to only on what's actually available online?
We do have contacts in various offices and city schools. And so where we can, we ask for that information. There's a couple problems with that, though, is that there's high turnover at city schools. And so often, and as well as they're extremely busy, and they're usually concerned about this year, and they're not as concerned about what was happening several years ago. In the case of zone maps, there is no other source than the district. And so in those cases, even though it's technically public data, they don't publish them online. And so in those cases, we had to go directly to the planning office inside city schools, and they were very good about giving us, all the maps that they had. But they even reached a point in their records where all they had was printouts of what the zone map looked like. And so in those cases, I had to use ArcGIS to kind of reconstruct, as far back as we could, what the zone shapes were. And so that was kind of an interesting side thing to do. But yes, I mean, it's always best, to ask them directly, hey, is there a version of this somewhere that I can have? It's just that you have to find the right person. And sometimes that can be a tedious process, particularly for stuff going back many years.
Thank you. Very interesting.
Okay, there are two questions in the questions and answer. I will read the first, and you may be able to read it as well, Kurt. So from Anita Kar, do the curation, availability, and quality of these data sets depend on the current administration and their policies, or are they protected or independent somehow from such vicissitudes? First time I haven't used that word.
I think it depends on the current administration. I don't think that there's ever any, they're not trying to hide any of these public documents. It's just that it's not a priority for them to make them available, I think. I think it's just not anyone's particular job to make sure that there is a longitudinal curated set. And that's no one's fault. I just think that that's how, in a lot of public agencies, I think that's how it plays out.
And the federal sources are almost always connected, always collected. But I've been using them for almost 20 years now, and like during the Bush administration, because of money flowing in budgets, it took sometimes 2 or 3 years for them to update.
Yeah.
But they do eventually update. The state ones are there as long as the state is doing a particular policy, and then once that policy is done, that website disappears. So they're in place, but then they disappear because policy's moved on or the budget's no longer there. So they are ultimately all ephemeral in the end, which makes it difficult.
Okay, and another question is from Eric Michang. How much time would you say you spend finding and understanding the data sets of interest? And is the getting of the data better than in the past or more complicated?
I think it's getting easier. I do like, when the question to how much time would I spend, it's all my time. It just happens to be my job. But some data sets, like census data, for instance, you have to understand the mechanics of getting it. And once you do that, you're okay. You still have to understand things about margin of error and things like that. But the data sets of interest, it's project dependent. And so it's not like we go, because there's so much that you could be gathering. I think that, like for instance, the real-time data of buses, we kind of stumbled across the fact that that was available, that became available. And so we just said, well, let's start to collect it and see what happens. With other data sets, it's this facilities index thing is a particular project that happened. And so once we decided to look for it, it's pretty time consuming to find the right document where you're, and you might think that you're done, and then you're realizing you're missing a piece that connects two things. And so I think the question about is getting data simply better than the past. I think that it's this problem of there is more of it available, but it is less clear how good it is until you're actually using it. Because of this, it's very easy to post something to an open data site, but if you don't have any supplemental materials that explain it, you can make a lot of bad mistakes just because you don't know what the assumptions were for the people that are making the data set. And so I think it's easier to make mistakes because it's easier to get data sets that are kind of unbound by by rules. And again, that's where this curation step, I think, becomes important, because if you could collect some of these data sources and then go through some kind of vetting procedure, for instance, anything that pertains to the school district, talking to people at the district in certain departments, you might be able to get them to basically look at it and say, well, this looks valid to me. This seems correct. In the absence of that, the best you can do as a researcher is say, well, here's where I found this data source, and from all I can tell, it's valid, but I can't prove it. Now, less true for, if you, like, as Mark said, if you're dealing with the federal or the state data sources, these are cited widely and considered to be the gold standard in terms of accuracy and timeliness.
Okay, and I had a question as well, just speaking from our motivation from IDEIES. How often do you think it would be useful for there to be, say, at IDEIES, a centralized location where you could have a copy of all the data? Like, might it be useful to have census data here because it might make it easier to cross-correlate it with other data sets?
I think it would be. The part that is a little bit frustrating about, so I was mentioning that there are packages now in R and Python that make it quite easy to use API connections to the government website. But sometimes those packages have difficulties crossing format changes in the data, and the census data doesn't sit still in terms of the formatting. They will change the way that they're exposing it. They're going to change the shape of the file. They're going to change the code that's used to get a particular variable. And so it would be nice, I think, particularly with census data, to have a central resource and standardize some kind of collection, standardize the pulling of that data. And, so that when you're doing a lookup for a library, that you're not changing it between, there was some change that happened in 2010, and if you're going to go 2009 and then 2011, you don't have to rewrite your code every time. And so there's some of that I think is helpful, as well as the way that the census exposes their shape files. The naming conventions change, those kinds of things. I particularly got so frustrated with that I stopped using the API for the shapes, and I just downloaded all of them onto my computer so I didn't have to worry about that package failing. So it would also be useful, I think, in terms of zone maps for school districts, once we have them, to have a set that's in a central place. Because if you're doing research on the city, particularly elementary zones, elementary schools, those zone maps are important to have and say a lot about the shape of the school system.
Okay. Anybody have any other questions?
I have a really quick question. First of all, great talk. Really enjoyed it. I'm wondering, Kurt, have you been in a situation in which you used Freedom of Information Act to acquire certain data sets?
I have not. I haven't encountered that. No.
Yeah, part of the reason I'm asking is that you talk about the certain confusing data sets really require a lot of time to process. I'm just wondering whether such a mechanism in which they talk to the producers of such a data set, saying that why do you guys just post Excel instead of PDF? And the other situation is that the people saying that they are giving you public information, but that information is only real time. They do not give you history, do not get the the time stamped data. Is there a mechanism for researchers to directly work with producers to create better data sets?
Yeah, I think we, in terms of data that the district generates, we do as much as possible to get things directly from them. But again, in some cases, the information is lost to time, and I don't know that.
I'll take a swing at it, Kurt.
Yeah.
So I think, a lot of public agencies have as much turnover as any other kind of business or agency. So often the responsibility for posting data changes hands. And that can lead to some variance in how data is pushed out, if it's pushed out or where it's pushed out. And then I think also, a lot of those things like that facilities report, that's the format it's expected in from the state of Maryland. And so that's the format, they don't have lots of time to turn that into something else. Although I think your question is great, and the answer is less great, perhaps. It takes time, personal relationships, commenting of like, it'd be a little bit nicer if this were in a certain format. And then another to your FOIA request, Freedom of Information Act type requests. I have colleagues that are data directors in other districts, not Baltimore City. They intentionally, when they get FOIA requests, they actually expose a data set that is related to that FOIA request it's actually, to fulfill their public responsibility to do that. But it's also, if someone FOIAs for something, that means somebody else probably also has the question. And so their own saving themselves time is to just go ahead, meet that request, make a data set, and just put it up on a public website, and it's there for everyone at that point. So there's an interesting mechanism there of signaling to a data owner of something that people want, and then they're filling it to kind of get them off their back, but it's now publicly available in a format that just about anybody could use. So, I think it's somewhere in the mix of those things. There's some just general agreement across a broader society of these things are useful in many, many different ways. But it's that personal relationship that often helps data owners see the value to others of how they can put it out. It's a great question.
Just to add one thing to that, because of the partnership with the school district, I talked a lot about zone maps. Again, they're concerned about this year and next year and not about 5 years ago. And so since we are, we do sometimes, it end up being kind of a reflexive relationship. And so for the zone maps, I ended up doing work on collecting all of those zone maps. And I kind of did my own curation, asking them a lot of questions, and basically gave them back a set of their own maps, but in a way that the next researcher that requested them, they could give them a collection rather than possibly disconnected maps that had slightly different formats and things like that. And so working with these partners can lead to kind of a virtuous cycle of helping each other out for those kinds of requests.
Okay, I mean, this was very interesting, very good discussion, very interesting questions. I think we're at the time now where we're going to have a 15 minutes break. After that, there will be 5 panelists who each will give an introduction of some 5 minutes, and then people can ask them questions. Is this about right, Caroline?
Yep, that's about right. So we will be coming back together at 3 o'clock for the panel discussion.
Yep.
Okay.
Cool.
Thank you.
Thank you all.
at 4. So I have a hard stop at 4. So I'm hoping that we, manage to have a good conversation till then. And if I drop off, it is nothing other than I have this hard stop, and I've asked either Gerard or Tinglong to close the session if that's the situation. So without further ado, if we can go in the order that the panelists were listed, starting with Jim and then Charles and Mark, that would be great. So Jim, if you don't mind starting us off.
Sure. Thanks a lot. And it's a real great pleasure to be here participating on IDEAS. Gerard and I have known each other, and Tomasz and Alex, and I just think what you guys do is incredible. I'm glad you're seeing more and more faculty using the resources available. We've, myself, I've worked with Tomasz Budavari. We've done some work putting Twitter data on IDEAS and doing some research, and we got a couple of publications, so that was really, really nice. I can't wait until you guys have your annual conference. I really look forward to going and watching what other faculty and researchers do. Just to give you a little bit about my background, I'm an associate professor in finance at the Carey Business School, and I've been teaching there with Tinglong. We actually were next door, well, 2 doors down, and I've been there for about 8.5 years. I teach the finance course, the big data machine learning course, and I really, really am enjoying cryptocurrencies and blockchains. So I'm running a small little research project that at some point I'll try to see if I can get some space on the IDEAS servers. And we're trying to understand cryptocurrencies from a fundamental perspective. So what do we mean by that? In the United States, as you guys know, if you go drive up to your convenience store or gas station, you can actually, there's an ATM there that you can exchange US dollars for Bitcoins or Ethereum. So we're starting to count how many of those are across the United States. And the idea is we want to just plot them each day or each week. So then we can see a rise, and then that will be one of the fundamental indicators, right? So we're trying to think about cryptocurrencies from the very fundamental perspective as it intersects with the traditional financial markets. I think it's very, very exciting, very interesting with the number of unique wallets that are coming out, and Coinbase's listing was really, really interesting. I think there's over 50 million unique users. So why is that fun for a finance professor? Because it's this intersection between finance and technology, and us being in Baltimore and DC, we're very close to the regulators. So then, I get to interact with the regulators because I'm part of this Act, which is half industry, half the people down in government, the regulators, and they're trying to understand how technology is sort of, changing the landscape. So it's a very exciting time in finance. And so that gives you a little bit of background of myself. And I really enjoy cross collaborating with other professors in different divisions. And so it's a real honor and pleasure to be here. And with that, I'll let somebody else go.
Thank you, Jim. I appreciate that.
Sure.
I think cryptocurrencies certainly are on everybody's mind in some way or another these days. And you're right. I don't know if you know, there's a convenience store right near campus where there is one of these. I think it's Bitcoin ATMs. So Charles, if we could turn it over to you, that would be great to hear your remarks. Thank you.
Sure. Yeah. I won't have anything to say about cryptocurrencies, but another timely topic, turbulence. I don't know how close you are to a window, but it's quite windy out there today if you're in the Baltimore area. So maybe just use that as an introduction. So I'm Charles Mennevo. I'm in the Department of Mechanical Engineering, and I've also greatly enjoyed collaborating with Alex in the context of IDEAS and Said and Gerard and all the others. I'm Associate Director, one of the several of IDEAS, and so I've been involved with the Institute for quite a while, and it's been tremendous. And I was delighted to hear all the things that we heard from the speakers before. It's really fascinating, learned a lot of new things. So in my field, which is fluid dynamics and mechanical engineering, there is one type of flow, which is turbulence, which is very complicated. It's spatially fluctuates a lot in time. And as it turns out, computer simulations have started for probably the last 2 decades, making tremendous inroads. We can now simulate detailed, very complicated flows, and those simulations are very expensive. I don't have any slides prepared, but if you look at my background, that's actually, and if you look closely, it's actually moving slowly in time. That's a turbulent flow. It's called isotropic turbulence, and it was produced, it was generated on a supercomputer. It took many days to generate. I mean, much more than this, and it's in 3 dimensions and so on. And as it turns out, in this area, there's very few people who have had access to this very large data sets that come out of computer simulations. And so what we've tried to do, and so I'm coming to this panel perhaps more as a data producer and a database generator. And so of course, one is always also interested in what the users are interested in and so on. But I wanted to give you just a slight taste of generating these data and putting them out there for users to use. And so right now, the database system, we have a bunch of different flows, simulations. There are about, I think there are 9 different flows. We have about 0.5 petabytes of data. So essentially we store the entire 3-dimensional time-dependent velocities and pressures and densities, all these kind of things that you might imagine. And what we've worked a great deal with, and this is where things like SciServer and several of the infrastructure have been so useful, is to allow users to zoom into particular regions of the flow and only download the parts that they are interested in. We call this the synthetic or virtual sensors. So people can place sensors into this artificial turbulent flow, and it's been quite useful. So there's about 800, I think by now there's probably about 800 users of the system. Of course, there's some poor users who use it a lot. There's been about 200 or so papers published, peer-reviewed papers published on this. And so that's been quite exciting. I guess working on this has, I've formed a few opinions about, if you're a database user, things to look for. And maybe during the, I can probably mention some of these things as we go along with at this session, but maybe with that, I'll hand it to the next person.
Yeah, thank you, Charles. And actually, I did not know that about your background, so thank you for sharing that. I've seen that before. Thank you. Mark, if we could hear, if you just briefly who you are, and if you mind sharing some stuff, that'd be great.
Absolutely. Good afternoon, everyone. I'm Mark Stein. I'm an associate professor in the School of Education. I'm also the managing director of the Baltimore Education Research Consortium. And I fell into a relationship with Gerard and got introduced to SciServer and IDIES almost by happenstance. LinkedIn How kind of pulled me into something at some point in time. And it's been, although we haven't landed that grant yet or done those things yet, it's been very fruitful for me to think about how to extend. We do hyper-local stuff. We talk about Baltimore all the time, but how can we use kind of a local context to understand different ways that kids can inhabit space and cities and time and schools, and then start to think more broadly about, not just Baltimore, but other cities. And that's where I think SciServer and IDIES becomes very interesting. Because, funny little story, I remember first time talking with Gerard, and he did this little calculation of our data and kind of chuckled about how little it was. We don't do petabytes yet, but it's big to us kind of thing. But you could see where transportation, which is largely where we've been spending a lot of time, of how kids experience the city going from home to school every morning. In cities, they typically use public buses. And that puts kids in exposure to the city itself, which means I've got some colleagues that have a report coming out this summer talking to kids of, deviant behavior on buses and drug use and violent crime, etc. And then we expect our kids to land in algebra class and perform well. So it is a physical manifestation of the city and how we observe our kids doing their work. So I've enjoyed it. I've learned a lot, but I think the next steps, there's several next steps that are very intriguing to me. How can we take what we learn in Baltimore and blow it up to the entire country? We can do it in any city. We can do it in any country that has these types of public data sets available. What can we learn there? How can we learn about different societies and how they organize themselves to deliver education for kids? Those are incredibly intriguing to me. We've done some micro scale versions of them. But it'd be great to leverage SciServer and other resources available to do it at a bigger scale. And then I think the other one that's much less ready, but something that I think broader communities probably have to grapple with as well is powerful stuff comes from merging private data with public data. And so how can we cross that divide of, you know, data access, data privacy, security, all of those things, and interact it with public data sets? And then maybe even further, how do we help folks to benefit from that work in maybe curated sets or secondary or tertiary types of data sets that could be useful to other types of work that leverage both that public-private kind of access? So long-winded way of saying I love interacting with this, and happy to be here.
Thank you, Mark. No, that's really helpful to hear. And I will raise the questions that I put in the chat to not only the panelists but all the attendees, which is, you know, what public data sets or social science data sets more broadly would you like to gain access to that you don't have right now? Which data sets do you have that you could possibly share with others? And what types of data challenges prevent you from addressing your research questions or teaching needs? And I think Mark just raised a very good one, right, about private and public and the fusion or joining of them. And from the library and IDEIES perspective, I have the unique sort of position of sitting in both universes. We are fundamentally trying to think about how to reduce the burden on you to manage your data so that you can actually do your research and you do your teaching. I very much respect, you know, for example, the description that Kurt gave of all the data management curation things he's doing, and he has an expertise. Obviously, that's very highly relevant. But to the extent that IDEIES and the library can come along and perhaps help you with those data management, data curation needs, that's a really important theme of what we're trying to convey today. And we work very closely, you know, between the two units. And if you think about a life cycle, there are times when you need the data near the compute. IDEIES and SciServer is a very good way to do something like that. Or it could be that you're simply looking for a way to share or get a DOI and have an open access or public access version of the data. The longer term perspective, preservation, the training, the services aspects that Para talked about earlier. So between the two, between IDEIES and the library, we think we have a fairly substantial range of capacity and services that we can offer. So the more we can find out about the particular kinds of data sets themselves, the more, in my world, what I call use cases, you know, what are people trying to do with those data sets, either for research and teaching, the better in terms of how we can respond. And I will say that some of this is very timely to pick up on Mark's point about this idea of private and public data coming together. In fact, Mark is involved in this. The university is actually updating our data retention policy. It's prompted by the NIH announcement, which many of you may know about, around the data management sharing policy, which won't go in effect until January of 2023. But nonetheless, we're trying to prepare and think about well in advance. And one of the key questions is, how do you deal with restricted data? So in the medical world, that may be HIPAA. But in the student world, it may be FERPA. There may be other reasons why, you know, for K-12 students, or even financial records, why you can't publicly share the data, but you still want to do some kind of analysis around the data in a very public way. So those are some of the themes that I thought were important to bring to the picture. I'd be very curious to hear again from the panelists in terms of response to some of those ideas, but certainly the attendees as well.
So I'll jump in here real quick. So I teach a big data and machine learning class, and as part of that course, the final presentation, students are asked to go find their own data and come up with, a machine learning prediction model, supervised learning, something that allows them to exercise some of those things that they've learned. And what I think is really interesting, and Andrew mentioned this a little bit earlier, how he's combining different data sets together, right, in order to come up with some really interesting things. So I always have in the back of my mind, is there a way for IDEIES, if I come up with a particular problem or a student comes up with a problem, and I'll just give for example, suppose I want to predict, the number of ATMs across the United States. I want to put in macro variables. I want to bring in anything that's publicly available, that's available down in DC at those agencies, whether it's Treasury or it could be, the IRS or so forth. can I ask can I ask an algorithm to go find me a first cut of what are some important features? And it could be, you know, across all the different agencies in the government, right? And then it percolates a bunch of these features to me, and it says, you know, you can use this, this, and this, and this. So it helps me do my research, right? So the idea is that data has strategic value. However, you know, most of the times, unless you understand the data sets and you understand how to sort of link the data sets, it's very difficult to grab data from many disparate sources, right? So like, you know, Mark mentioned that he's working inside Baltimore, right? Maybe there's an indicator inside there about movement of people or transportations across certain, you know, grocery stores that had ATMs or so forth, right? How would I ever be able to see that data or understand it unless I work, you know, intimately or closely with Mark and his data sets, right? So is there a way that, you know, we could leverage IDEIES, somehow get all these data sets somehow linked together? And I don't know the answer to it, right? And then, you know, allow researchers, students, professors to ask a particular question, right? I'm trying to predict X, Y, Z. Are there any other data sets out there? I know the data sets in finance, but I'm trying to think outside of the box, right? So, you know, I'm always curious, you know, when that's going to happen, right? I'll give you one, for example, you know, if you have a company, you have an EIN number, right? And with that EIN number, that links your organization to many, many different data sources in the government. So that's the key that you need for a company, EIN number, right? For individuals, it's probably a social security number, but then we go into that personal identifiable information, you know, sort of, we start butting heads into some of those things, right? So one question is, you know, how can we use that, combine the data sets, but really not use the social security number, never reveal that that was a link, right? And so those are the things that, you know, I think would be kind of interesting. I don't have the solutions, but I know it could unleash a lot of value if we could solve that, right?
Let's just pick up a thread that Jim just said of, you know, he knows finance, I know education, like, how do we start to leverage what's inside our brains? So it's not what data sets but just knowing that linking identifier is usually enough to open up a lot of things, but some kind of curating some of the key pieces you might want to know if you want to link finance. And I just thought of about 3 different ways I'd want to pick his brain and pull some business information into educational type questions. So I think that would be an interesting curation of sorts.
Yeah, and I think it's not a fully cooked thought, I think, but one of the ways that something like IDEIES or the library can help, of course, is if we have common areas where data are served, curated, managed. You know, both of you have a very deep expertise in your fields, right? And you can imagine a way that the two might come together. But in some ways, I think of this kind of common data infrastructure and set of services and storage and so on as the way you get the breadth, right? So without being too deeply, and I can guarantee you, too deeply well-versed in finance or education, but having a sense of information science and library science, we think about how you broadly describe something like this. So at least it's discovered, right? At least somebody other than the two of you can actually even find it. And then if it's in a location where you discover it and you see how other people are using it and you see the toolkit or the toolbox that SciServer offers you, then you can start to build, you know, more systematically this kind of community or you know, communities of interest or practice. And that takes a lot of effort, and asking individual researchers to do that is asking an awful lot. So I think that's one of the things we're trying to think about is if we pool these collections, services, use cases, descriptions, identifiers together, can we more systematically build those communities? Charles, I know you know in the community, it's not necessarily social scientists, but you know in the turbulence community, you now have evidence of this, right? There are people coming together using the turbulence data sets, maybe across subdisciplines or maybe even other disciplines. Can you talk a little bit about some of those sort of success stories?
Yeah, I think as there was a bit of the awkward silence, I was thinking, you know, how to contribute. And I think the one thing we've noticed, again, as data producers, is that there is a subtle balance between how much you will invest resources, effort, student time, author, for the community, for them to use the data. And it's very, very easy, I found, to completely just miss the mark to some degree. You say, oh, I will put this data out here. And we've done it in other contexts besides the turbulence database, let's say. We've placed a lot of data online. It's there, and somehow nobody uses it. Either it's not known that it's there, or it's in a format that maybe is not very useful. So it's really a lot more is required than just saying, oh, I have this data, let me put it up online. It's almost like throwing it over the fence and hoping that somebody will use it. So I think there has to be a lot of effort, thought, invested in thinking, how will people use it? And one thing that may transcend areas, might be interesting to others to hear. What we found useful is to accompany, let's say, a new data set that you're providing to your community, to accompany it with a peer-reviewed publication or a set of peer-reviewed publications, so that others can have one point of reference. This has been peer-reviewed, people have vetted it, and so on. This data set was used to generate these particular points, let's say on a graph. Then they can start using the data and maybe reproduce those data points. And that generates confidence that they're reading the data correctly and interpreting it right, and then add to it or take the data in an entirely different direction. But we found that to be useful, I think, that when people can see a publication, they themselves use the data this way, the data is there, there's a few points of reference that you can make connections to. So that can facilitate a great deal, we found.
I almost want to ask Charles if, we can use his simulation engine, right? And then sort of, because Johns Hopkins is in Baltimore, and try to predict, right? I mean, suppose that we simulated a reduction in number of guns inside the city limits, how would that affect, health, right? Or if we simulate, we put up I'm just sort of making this up, right? We put up a business school, in the east side or the west side or another hospital, right? How would that affect the dynamics of, Baltimore City? Right. And then which lever makes the most sense? Should we add more teachers in? Should we try to reduce the number of drugs in the city, right? And can we somehow at some point, because we are Hopkins and we have a really strong healthcare, can we give people sort of Fitbits to wear around or Apple Watches, right? And then get all this data, put it on IDEIES, and have researchers kind of analyze this and try to make policy decisions using vast amounts of data, to the order that Mark sort of talked about, right? Every whatever 10 seconds or whatever the frequency. I think that would be really interesting, and then come up with some types of strategies. I mean, like one example is, what if we opened up, blockchains and cryptocurrencies, and what if Baltimore had a cryptocurrency exchange or something like that, right? Would that generate economic activity? I don't know. How would people congregate, right? Will people start moving towards wanting to learn more computer science, and, maybe it's learning how to generate smart contracts and so forth. I think that would be kind of interesting and fun. The other thing is, like, which parts of Baltimore, do we need to improve upon, right? And then how can we come up with some type of policy or recommendations as Johns Hopkins, and saying, maybe we need XYZ training center here or another school or something like that, right? Or maybe it's a bus line to get people into that particular area. But, I think trying to solve Baltimore's some of the Baltimore's issues inside, because we could have accessed the data if we built a really nice relationship with the mayor department, right? I know New York City provides a lot of its data freely available, right? And I just think that we could leverage the IDEIES platform and also our location inside of Baltimore, in addition to all the faculty and the wonderful things that people do in terms of research, and try to collaborate and try to solve some of these social sort of problems, right? Yes, sir.
Yeah, go ahead, Gerard. Go ahead. Yeah.
Yes, I've.
Oops, you went back on mute.
On mute.
Sorry, you went back on mute. Yeah.
I went back on mute. Okay.
Yeah, there you go.
Thanks. So as I mentioned in my talk, one of the advantages that IDEIES had with its original effort is that we had real domain experts of the data that we were publishing. Like Charles is one of the domain experts in social science. We personally at IDEAS, most of us are not that. The library has some domain experts, say on GIS and maybe in some other fields, but like for the work that Kurt did, no, it's just this really detailed mining of documents. How much of a domain expert do you have to be, and how much can actually be almost outsourced to people who do know about relational databases, about Python, about Spark, HDFS, or the technical stuff, who have some understanding of it, and how can we bring those people together in a somewhat efficient way?
Yeah. So maybe one thought, and SciServer is particularly useful for this, is the notion of derived databases, and in some sense, what we heard from Kurt. He's put a lot of effort in trying to congregate, aggregate data from very different sources, and he's had to, as we heard, right, make phone calls to the actual people and so on, and collect all of this. And so there really is, hopefully this will be coalesced in a derived database that now contains all these pieces, and then can be published in some sense in a piece of work that would be really an effort that's already been done, but now a lot of other people can probably use his efforts, and that's where I think as sort of academic societies we're not ready yet. I think there's right now the incentives for people to actually do that. Let's say for Kurt to now take the extra step and build a really unified, easily accessible database for others to do different research based on the same data. I think the incentives are not quite there yet. And in a way, I liken it almost like writing a book. So, you write a book right now in academia, that's part of the, you can get check marks for that. You create a database that everybody's using. To me, that's probably even more effort than writing a book. And it is a bit like publishing a book. And so that's another thing we want to we need to be working on to develop those kind of appreciations for the people who put these things together.
And I would just play off of that too, and maybe a couple of the different ideas. Maybe it's not the academics who do it, but academic publications and work, and talking about real problems that folks have, and showing some potential solutions that might work or not, can help data owners and other data publishers and public agencies see the value of, they're the first step, right? If they publish the CSV file, a lot of things get simplified. And so it's like, how do you connect both what we do as academics and showing value to public problems and questions that also engenders this, oh, I'd never thought about how my data could be used that way, and how impactful it, Transit in Baltimore talking about kids, it wasn't something that was there. And then all of a sudden it was like, oh, I now understand why a bus shelter is an important thing, right? And like, there's both sides of that I think there's lots of power there.
I think, Mark, if I can interject, I think you bring up a very good point also, that this, what I said in some sense is not just restricted to academics. A lot, I probably, it's safe to say, our best authors are probably not in academia, right? So you can have kind of public-minded citizens building up databases and in some sense, making a contribution that could be as valuable as writing a book. Doesn't have to be in academia, indeed. Yeah.
And I think, but both of those are critically important to kind of how we teeter-totter towards something that we're all kind of talking about envisioning being a thing. That's great.
Yeah, but just, to extend a little bit of that and then go back to what Charles was talking about data sets, right? I mean, I look at my daughters, I have two daughters, 12 and 14, right? They're on their phones all day long, like watching videos, right? Like TikTok videos. And I'm thinking to myself, I wonder if we can make little videos of data sets, right? So they can see what's out there, like 1 minute papers or 1 minute data, what you're looking for, but make it interesting for the next generation of, that's coming up, right? And then how do we engage sort of the younger generations to get involved with data and enjoying data and analyzing it and so forth, right? Because we're going to have just more and more data as we continue, down this road. and you know, being able to process it, being able to manage it, being able to understand it, being able to pull things together. I think it's fascinating and interesting. But you know, at the same time, right now, I mean, you need a certain level of expertise to sort of do this, right? And so, is there a way that we can sort of lower that the technical expertise so we can get more people into the conversations? I think it'd be pretty interesting. But you know, there's this one company I thought was pretty interesting. It's a hedge fund. They don't tell you what the series are, right? They sort of transform it so you don't know. But then they have people make machine learning models, right? And there's a competition. And so then, you know, there's a leaderboard, right? And I wonder how we can sort of gamify some of the some problems in Baltimore, and, you know, have some of our undergraduates or, you know, students in high school use the data, try to come up with some kind of prediction model in order for a better social outcome, whatever that may be, right? You know, because, you know, you can code anywhere. You can pretty much, as long as you have access to the internet, right? You can do it in your dormitory room or, you know, pretty much anywhere. The issue is, can we get data? And I think this is a conversation with the city, and I don't know who has a relationship, but, you know, how can we get more of the data in the city so we can analyze it, maybe put it on the IDEIES platform, right? Because I mean, obviously some of the data is going to get sensitive, right? But we need a trusted brand to make sure that we adhere to, you know, all the, you know, necessary requirements, right, to preserve that data and that trust.
Yeah, Gerard, please.
Yeah, so I had one question that was related to what Jim said originally, which is, I think, one of the big problems for what we call the long tail data. It comes from so many different sources and backgrounds that it is very hard, say, to come up with a single way in which you describe it all, you know, so that it makes it easy to find. But so this is what I always hope that the library particularly could help with how do we register these data sets? We don't just put them in IDEIES or in some folder in SciServer, but in a place, in a kind of formalized place that then probably does need help, assistance from people who can describe the data at some level. So how much do you think your work, how much are you willing to do, or how much do you expect other people to do to describe the data so that you can find it? And that a group like, say, you take, you know, librarians who know how to categorize things, and then IDEIES and SciServer can maybe help to make it easy to do something with it.
Right. Yeah, really good point, Gerard. And if you've been following the NIH data management sharing policy announcements and updates and resources, one of the resources they describe is these so-called generalist repositories, right? So lots of disciplines, domains, maybe even professional societies, who knows, even publishers at this point are running data repositories for particular disciplines, particular communities. But what about exactly what you described, a place where the data, and it's not mutually exclusive, right? One good thing about data is it can exist in multiple places, right? A physical book is on a shelf, it's on a shelf, but data doesn't have to have that kind of singular location characteristic. Can it be described in these rich ways so that your own discipline can go, again, very deep and do the types of, you know, sort of only unique kinds of research or analyses that someone with that expertise can have. But then they are also available in generalist repositories described in this broader way. So, you know, it's very much this, I've mentioned this to people in IDEIES before and to colleagues in the libraries. I think of data as a new form of collections for libraries, right? And libraries have a collection development strategy when it comes to content. So we need to think about data in that way as well. And, you know, data services group in the library in many ways is leading that effort. So we do have, yeah, and Mara has just mentioned about the JG Data Archive in particular, so thank you for adding that. Looks like we have a question or maybe a comment. And Lin Xing, I don't know if you want to say more about this, but she mentions that one possible way to match data from different sources is to use fine-grained geocode for meaningful spatial units to match in the appropriate aggregates. So thank you for sharing that. Did you want to say more about that? Or are you just helpfully providing some feedback for all of us? I think she's still here. I'm looking at the list. I do see her name, but maybe she's not right online at the moment.
Do you think
So
what she means is like you put a pin down on a map and then you get all the possible data sources with that geolocation? Is that the idea? That would be really
think
I
interesting.
speak.
Yes.
Do you hear me?
Yes.
yes,
Hear
yes,
you.
we can hear
Oh,
you.
good. Okay, I thought I could not speak. So
Please.
for myself, I really would be really great if we can have. Well, I use confidential data. So confidential data will offer very fine-grained geocode. I know that we cannot use the individual ID or organization or economic, entities ID. Those are very, very privacy protection issue. But if we can aggregate the information from different sources to a geocode level, for example, I would like to going down to block groups in a census, definition. So it's much smaller than census check. And if we can do, because we have if different data sources have the Xcode coordinate, so where the data points come from on the map, right? So then you could actually aggregate any, mean, median, standard deviation, different kinds of measures of the particular important thing, ATM, machine, or things like that. And then we could choose to match into my very, HIPAA data and APA data, or, all those kind of data, or any other public data. So in this way, we have enriched our data, whatever data you are interested in writing a paper or doing a project. So this, I think, could be done. I think this, if you have the XY, coordinate. I'm just thinking something is really feasible that is also useful. It's kind of like a contextualize what you want to study in the neighborhood, small enough neighborhood, so that we can maintain as much as variation as we can. I'm done.
So I'll mention one thing. I'll mention one thing that's along the lines, and we did this with IDEIES, and we had Gerard and his group really help us. We had geolocation data on cell phone movements, right? And so basically we had latitude, longitudes all over, but it was an explosive data set. There wasn't that many columns, but in terms of the number of rows, I think it was like 60 billion plus, right? And there's no way we could have done it. So we asked IDEIES for a lot of help, and they helped this. And then basically what we did was we dropped pins on Under Armour versus Nike, and we calculated the volume of foot traffic. Now, it wasn't every cell phone, right? So it's some sample of them. And then we tried to link it into some kind of pairs trading for Under Armour and Nike. And we actually published that paper, but that was built specifically. We couldn't have done that research if it wasn't for IDEIES. And Gerard and some other of his colleagues helped us sort of index that large data set, right? And I think it's what you're saying is really, really interesting. The issue is, how do you get the data? And that's the biggest challenge. But, you can imagine if Hopkins was working with the city of Baltimore, or maybe has sensors like the Internet of Things. I think those things are really fascinating. But again, the constraint is, who's going to allow you to have that data? Because once you have that data, then it gets really, really exciting and fun to do. But then you have to be careful, right? You have to preserve people's, privacy. So you have to do it in the right way. But how you're thinking about it, putting it in blocks, right, makes a lot of sense. I think, the census, I don't know if you guys have seen the websites. They have some really great data stories. They have some amazing data sets there. I thought it was just the population per year, but it's not. It's, you can look at a lot of very interesting things by these, tracks, right, across America. And I think it's fascinating. And all of us know the COVID map, right? And you can sort of see it in different regions inside the United States and different, tracks. It's fascinating. I think it's really interesting. But, can we go even more granular? At what point do we go too granular? And now you can identify that particular person, right? So, those are the challenges that, what's the right balancing point? What are the right checks and balances as we do this research, right? How do we sort of set up the ethics of this kind of analysis, right? I heard somewhere that, even if I don't know your name or whatever, all I need to know is your zip code and when you were born or something like that, right? Or a date of birth, whether you're male or female, and then the state that you're in. I can almost identify you pretty well, right? And you know, so as we are trying to anonymize the data, you know, when does it work? When does it not work? I think those are some important questions too.
So I want to follow up about the geocode. The point is, once you matched, you will hide the geocode. Then those data could be public use. You see what I'm saying? So I have individual level data, and then, you know, it's on my side. I already have a license, but you could. I mean, there's the way that is really not, you know, hiding the ID that will make this more varying, you know, contextual variables available. There should be some way to deal with that. So, for example, you have two sources of data. One is in the individual level. Individual's ID is also scramble ID, and then but you do actually know where they are, you know, hidden somewhere. The, you know, the confidential part of the data. You use the confidential part of this individual level data, and then the other individual level data. You match the things that in a geocode, which is a higher level than individual. After match, that even the geocode is hidden. But you still say that here is somebody's contextual variable. You see what I'm saying? There's a lot of different ways that you can hide the ID after the match job is done.
Thank you. Thank you for adding that. That's very helpful.
There's some on that. Sorry,
yeah,
because it came up from LinkedIn. Does the library have experts and on things like HIPAA, personal identification, FERPA, experts on, we can bring you, we have this data, we would like to share it. How do we make it de-identified enough?
Yeah, so I'm checking. We have 17 minutes. This is a conversation that could go on for a long time. So I should let Mara speak as well. Certainly, it's her group that does this work directly. So the short answer is yes. There are people and training that is around exactly what you described, and I'll let Mara speak about that more than I will. But what I will say is the complicating factor from a university policy perspective is, as some of you may know, is this concept of a covered and HIPAA covered entity, which, as far as I know, is a legal designation about who can handle HIPAA data. That's a very simplistic response, but the issue is that not all of the university is a covered entity. The School of Medicine, the IDIES, portions of IDIES, so on, are the HIPAA covered entity. So part of this data retention policy update working group that I'd mentioned earlier is actually looking at this kind of question in terms of who can handle HIPAA data, who can anonymize it, who can de-identify it, and so on. But there's no answer yet to that question in terms of whether the rest of the institution can start, from a policy perspective, be able to handle that kind of data or not. Mara, I know you might probably want to add something, so I'll stop talking.
Sure. No, I thought that was great, Saeed. I'll just say we do a couple things in data services. So one is that we offer consultation and a regular training that's offered several times every term on de-identifying human subject data. It's not that we do that work directly, so it's not like submit a data set to us. It's really educational on learning the goals, best practices for working with human subject data and identifying it for sharing. Really our angle is to share beyond the research group, typically looking at what are the standards for openly sharing the data and when can you meet that threshold. Some of the examples that came up are things that are coming up a lot for us in terms of advice about when you're actively working with a sensitive data set, like, for example, individual level geolocations, that type of thing. It's very sensitive. We oversee the Esri software. A lot of it is software as a service, so web-based software that exposes that information well beyond what the regular expectations might be for that type of data. So that's something we offer some advice on, especially looking at health data. And same thing when people are sharing data with us in the JHU data archive, when they're done with that active phase of research. It's not, again, that we stamp the data is fully de-identified, but we do review it and, iterate with researchers if we identify any problems. So that's the type of thing that we're working on right now. But I would say, and Saeed, I think you kind of alluded to this too, this is sort of a growing area of concern, both with the NIH policy, but with the proliferation of the use of GIS in new areas and how finely we can get data about individuals and their locations. We're seeing that come up too. So I think an area that we'll continue to work on.
Yeah, and I would just add that, the HIPAA is perhaps one of the most common use cases that we encounter, but there are others for what constitutes restricted data. And that's one of the reasons why I reached out to Mark, who kindly agreed to be on the working group looking at data retention policy. And I believe Brian Caffo from Public Health may be on that group as well, because public health talks about things like data from indigenous people, right? So there are other kinds of use cases about broadly speaking, sensitive or restricted data. And I think we're trying to consider that through this data retention policy update, thinking about NIH, NSF, and other funding agencies as well. Tinglong put a comment in the chat and a question, which is a really good question. And I'm hearing about this in multiple forums. So I talked about information science is my research area, but I'm really an administrator these days. So I end up in a lot of forums talking about the university's approach to data and storage and so on. And this is coming up over and over again about, can we have some sort of catalog of the data that's at least served up by Hopkins? Let's start there. I say that understanding just how complex that is. I don't mean that to be trivial. I don't have the short answer is no, we don't have such a catalog right now. A better answer is there's real interest in this for lots of reasons, for probably the motivators that you have for asking the question, but also from an administrative perspective in terms of storage. Some of you are aware or perhaps even connected to this AIX, this big AI big data initiative that the university is talking about as well. So it's come up in that context as well. Again, probably a much longer conversation and maybe something for one of our follow-up sessions. But anything we can do to work constructively toward this idea of having a data catalog for the university, I think will be very well received. I just don't have a very quick answer about how we might do that, but I welcome feedback on that.
So, one suggestion is, I know we have a lot of really, world-class natural language processing folks, right? And so, can you take the abstracts that have papers that are published and drill it down to a couple of words and use those as tags, right? And then sort of cluster the universe of publications, right? And I'm going to put something, I just recently heard about this woman. She's actually a professor. She's brilliant. And Julia Lane, she's basically mapping published papers to their data sources. So you could actually see which data sources have a lot of the publications that are coming from it, right? As a way to try to value a data set from an academic perspective, right? So, that's also a nice way for people in a particular area to understand what's going on the cutting edge and what data sets are being used a lot, right? In terms of providing a lot of value. And maybe it'll spur some ideas how to combine that data with some of the data that you're using. But I haven't seen too many people try to actually, bring the published work, find the data source and kind of make that link, right? So those are two things that would be really, really interesting. And, maybe that's something that IDEIES could do in conjunction with the Johns Hopkins Library and so forth, right?
That's a great suggestion. And I know this is so I have a current NSF grant looking at things that are related to this, and NSF is interested in this as well, as you might imagine. And I suspect most funding agencies are in terms of the impact of what they're doing and having a better record of the outputs. We have our 5 most significant outputs and all those things in the resumes, but I think in a more systematic way, funders are actually very interested in as well too. So that's certainly something to follow up with. Oh, there's something else in the Q&A. It's from Linsing again, and saying, oh, I think it's meant for Mara about confidential data. Did you say you can handle health confidential data? And again, I'll let Mara speak, but I'm fairly sure I know the answer to that.
So the answer is no. The short answer is no. We don't want to see the confidential data, and in most cases that data should not be shared with us, but we can work with folks working with that data to provide advice on how to work with it. When data is coming to us, we're typically expecting that it is moved beyond the confidential state to can be shared state. And we will certainly provide feedback if something that doesn't meet that. No problem at all. If something doesn't meet that, we'll communicate with that and delete that data as permanently as possible from our brains and our computers in all online spaces. But so yeah, if people are working with that, we suggest they reach out, don't share anything with us, and we can go from there. And same thing for working with systems that we manage, like some of these Esri systems. Don't put it in there, reach out. We'll offer some guidance about where that goes when you put it different places and some options.
Yeah, this data retention policy update group that I mentioned, one of the working groups that I'm leading is around storage and infrastructure. And this is one of the questions we're trying to explore is where can you have restricted data right now across the university, not only medical or HIPAA related, but where are there restricted data? Where is it appropriate and acceptable to have those restricted data? And then how do we potentially process them, connect them, or make them public, so on. I think this will be a key part of what we're looking at. Those working groups are focused on policy and recommendations, but we're trying to keep an eye towards implementation. If you actually had to do something as a result of those, how would you do that? So I'm just keeping an eye on the time. We have about 5 minutes left. Did folks on the panel want to add anything? Are there any other things from the attendees? Because it would be, having 5 minutes to just talk about possible next steps would be useful, but I don't want to cut anyone off if there's questions or other comments. Give it about 15 more seconds.
I just have one just to bring it back to public data. We got in the weeds of the private, which I'm fascinated by, but like just trying to pull some threads together of what would be incredibly useful. If we could abstract cities, Hopkins has a deep interest in cities and humans in cities. How can we abstract some of these things that maybe is in Jim's head or maybe is in my head, but there's a handful of things that are important to humans, and then look across cities and maybe engage with city governments. I know we've got whole centers that work in that space. And then as the library, trying to coalesce some of that stuff together, because, I'm in education, but I pull from all kinds of different disciplines to pull in. So like that kind of meta thing, which SciServer could certainly power and the libraries could power, I think would be incredibly powerful for students, for us as researchers, and there's a public good on the other side of it. So I don't have the answer to it, but yeah, that kind of direction would be highly leveraging Hopkins for what it can do.
Yeah, no, I think that's very compelling. One of the I guess I was going to say complaint, that's probably not the right word. One of the observations, there you go, I have about, the university's priority of helping, or not helping necessarily, but engaging Baltimore City and being a partner with Baltimore City in terms of addressing some of the issues that we all believe are common. And absolutely nothing wrong with things like hiring locally and so on. But what we don't have is a data, manifestation of that view, right? And Mark, if I'm understanding correctly, I think what you're suggesting is we can come up with a vision and a strategy about a data manifestation of this. We are partners with Baltimore. I like the way you put it as sort of abstracting cities. And then from that can flow, a lot of these ideas about where the data sit, how they get processed, who manages them, so on. I think it's a really good idea. And I will turn to my colleagues in IDEIES, Tinglong and Gerard in particular, but anyone about, we do think this is the first workshop. We didn't want this to be the only time we speak, but starting conversations is part of what we're hoping to do today. So I think that may be one of the themes for us to explore, for example. Is what does something like that look like? Who gets involved, and how do we do that? But I did want to also ask both of them to comment on what they heard today and maybe some next steps as well. So Tinglong, if you want to go first, and then maybe Gerard after that.
Oh, sure. I think I had this brief conversation with Jim before the panel. I think Jim's suggestions to deepen the collaboration between Hopkins and federal government agencies. Because there are this is plenty of room for that, and I think obviously we have the best experts who can do that and who know how to get the data shared and how to use the data. And people are asking right with your questions. There should be just maybe for one of the future events, we can try to plan something for that to get the people from the federal government and also get people from Hopkins to facilitate the arrangements like that. Just one quick suggestion, that's my exchange with Jim.
If I may, so I think indeed this focus on the city and on Baltimore specific that LinkedIn is also favoring might also play well with some other effort that IDEIES has already had with, I think, Baltimore City or 21cc, where we're trying to follow up on that, so that it might definitely work there. So yes, I think we could try to focus on that, and it is somewhat well confined, and then later we can generalize to the rest of the world. One thing is for all these possible projects that suddenly pop up and everybody wants to work together, who has the time, who has the resources, who has the money, how do we fund it? Do we at some point want to come up with some out of some of these, a couple of more of these symposia, maybe, okay, we gather some group together, we write the funding proposal that will get the money, and it's multidisciplinary and all of that. Because it would be great to work on this. If deans are suddenly saying, here's a lot of money, we can hire more people and we can do all of this. But so I'm not as high in the politics as you guys are. So like, what do you think? What would be our possibilities that we could actually get that?
You're high. Come on, you're high in the political still.
No, I'm not.
You move a lot of data around and you move a lot of weight around and budget.
But anyway, but some people like Charles or
those are
so, yeah.
those are not the same thing. To move actually things is not the same as being high up, unfortunately.
Okay, so Eric put something in the chat, and this is exactly what I was trying to get at, right? This is really interesting. So this professor, Julia, she actually made it a Kaggle competition to link the papers to the data sets. And she had over 700 groups competing around, right? So I wonder if we sort of set up the problem in a Kaggle competition on IDEIES, right? And then we can have the community kind of like crowdsource the answer, right? It's sort of like what, happened with SciServer and, identifying the galaxies and so forth, right? I wonder if we could set up that kind of framework. If you have time, please do take a look at this link that Eric put in there. It's wonderful. It's really interesting. And I think, maybe that's a way forward because everybody has limited time, right?
I have to say, I like this a lot, and it goes together with what I was thinking, that these data sets, they have to be linked with papers. So what this suggests is a lot of times the papers appear, and then maybe the data appears later, and it's not at the same time. And so, producing this kind of union, even if it's after the fact, might be quite useful. This is quite an interesting idea.
Yeah, I like that. I think sometimes you have data sets, you also have a code that produces all the figures, all the tables in your paper. I recently did that, posted everything on internet. Guess what? It actually increased the citation of your paper because people will start to try to replicate your paper, and people try to develop new results.
So who's in charge of this room? I think Jose is trying to get in. Does anyone see him trying to get in?
I think we're at the top of the hour, right? Like we are.
Okay.
It's
All right.
4
We'll do it
o'clock,
next
right?
time. Yeah.
Yeah, we do it next time.
Unfortunately, I don't
Yeah.
see him. Sorry.
Oh, it's okay.
So shall we call the day?
Tinglong, Gerard, do you guys want to wrap up?
Yeah, and Gerard, go ahead.
Yeah, well, at least I thought it was very interesting. A lot came out of this. I think we have some plans for the next few meetings of this. We hope that most of you might be willing to attend that again as well, if it's becomes a more focused issue, not just public data, but I think there's a consensus to focus it on Baltimore, which is probably good because that's where we live, and it has plenty of problems that we might try to solve.
Yeah.
I don't know at what time scale we were thinking of doing that, maybe every 2 months, something like that, 3 months.
So we were going to send out a survey next week to all the participants and gather some more information to help us with our next workshop.
Perfect. Sounds like plan.
All right.
Thank you, everyone.
Okay.
Good. Yeah, thank you,
Thank
Carey.
you,
Thank you all very
everyone.
much.
Bye-bye.
Thank
Great
you,
weekend.
everyone.
Bye-bye.
Thank you.
Bye.
Bye.